This customer utilized a sulfuric acid solution for heavy-duty cleaning. The spent acid along with the washdown solution was being collected by a 25-foot deep catch basin. The metallic, self-priming pumps being employed were deficient in two areas. First, their performance specs were insufficient to prime the pump given the depth of the catch basin. An attempt to correct this problem was made by moving the pumps from the top to the center of the basin, which alleviated the priming issues. However, it exacerbated the second issue with these pumps, the materials from which they were constructed. Moving them lower into the catch basin saw a marked increase in the corrosive effects of the environment they needed to perform in, and they soon proved no match for the harshness of the site to which they were subjected. Ultimately, this resulted in frequent downtime and pump failure. Clearly, an alternative solution was called for in order to eliminate the corrosion of the pump parts, create sufficient head to meet the established conditions of service, and reduce the overall level of pump maintenance required. Application-driven engineering has always been standard operating procedure at Vanton Pump and Equipment Corporation, the leader in the manufacture of thermoplastic pumps. With over 65 years of experience, Vanton engineered a new set of pumps specifically designed to address the needs of this application. After considering the liquid to be handled, the flow rate, discharge rate, and head needed, along with operating temperatures and the physical location of the pumps, Vanton's engineers designed the vertical centrifugal 24-foot-long thermoplastic sump pump you see here. Over the next few minutes, we'll provide an overview of the assembly process of these pumps and explain why Vanton is confident that they will perform in extremely harsh conditions year after year. We begin by pre-assembling the cast iron motor mounting bracket assembly, the cover plate, and the first section of the column. Here the technician is inserting a column adapter into the first section of the column, which will serve to align it with the next section. Both sections will then be bolted together. It should be noted that all hardware exposed to the acidic fluids is non-metallic. The column adapter securely houses a silicon carbide outer bearing, which we'll discuss in more detail later on. This process will be repeated to join together each subsequent column section. At this point in the assembly process, you can see the two initial sections of the column aligned and bolted together. After installing the third section of the column, the technician mounts the discharge pipe support on the column, which will support the 4-inch discharge assembly. Once the discharge pipe is fed through the column-mounted support, it is then threaded to a flanged coupling which serves to ensure the integrity of the discharge. After this, another column adapter containing the silicon carbide outer bearing is installed, which in addition to enabling the further extension of the column's length, also aids in reinforcing the growing length of the column. The outer bearing and the column adapters have been designed to flawlessly engage with the ceramic inner bearing, which is incorporated into the shaft sleeve assembly to ensure optimal performance. At this point, the technician will insert the 304 stainless steel shaft, which has been sleeved in CPVC, through the length of the column assembly. The CPVC sleeving isolates the 304 stainless steel shaft from any contact with the acidic fluid being handled, which greatly enhances the lifespan of the pump's components. Once the shaft is fully inserted, the technician secures it with a lock nut and begins to install the next section of the column, to which the upper flange assembly of the hydraulic head is mounted. Once this is completed, the next step is to install the stuffing box cover, which houses the final outer bearing, which will mate to the last ceramic inner bearing. A keyed impeller is then installed on the end of the shaft with an impeller lock nut, and the balance of the 4-inch discharge pipe assembly is situated. Now the technicians install the casing cover O-ring around the stuffing box cover and wrap the threaded end of the discharge pipe with Teflon tape to seal and help secure the discharge pipe to the elbow of the casing assembly. Once these are aligned, they also mount a strainer basket to cap off this assembly and securely through-bolt these components together. Moving to the other end of the pump, the technicians begin installing the water flush manifolds to the pump, which will provide lubricating water to both the line shaft ceramic and silicon carbide inner and outer bearings. Vanton engineers have opted to employ fresh water quench for the bearing lubrication requirement on this project, and it is through the Teflon tubes being installed from the manifold along the length of the shaft that the lubricating water will travel. 2 water flush manifolds, each lubricating 3 bearings, are employed to ensure that sufficient fluid reaches each bearing assembly. By engineering this pump to ensure only non-metallic contact with the fluids being processed, Vanton engineers have effectively removed the threat of chemical attack or corrosion and have ensured the pump will have a long service life despite the harsh environment of its location. Here you see the finished pump, showing the motor bracket arrangement and steel cover plate with plastic underlay. Everything you see is constructed of CPVC, including all of the regular bolts as well as the hydraulic bolts at the bottom of the pump. The only exceptions are the hydraulic head consisting of the impeller, casing, and casing cover, which are manufactured in PVDF. Once assembled and tested, the Vanton 24-foot-long vertical centrifugal sump pump is prepped for shipment and shown here along with 2 additional matching pumps designed for this specific project. This is just one more example of how Vanton engineers solutions for the world's most difficult pumping problems. Their ChemGuard, SumpGuard, FlexAligner, and pump tank systems comprise the world's most comprehensive line